We want to gratefully acknowledge Josh and Judy Weston, who make this cafe possible. And who have not only supported this inaugural season, but who have committed to this adventure again next year. It is so exciting to be able to see and satisfy this tremendous public thirst for science and specialty cocktails. Just by show of hands, I want to know how many people here have been to a SciCafe at this museum before? Very nice. And how many of you have been to more than one? How many of you have been to all 9? Tonight is the 9th. Anyone? Anyone? Oh, right. Diehards. Very nice. As those of you who have been here before know, tonight we've really expanded our horizons. We've moved beyond the Gottesman Hall of planet Earth and into the Kuhlman Hall of the universe. We're also switching up the format tonight. Instead of our typical speak first and then Q&A, this session is going to be entirely Q&A. And you can tell us what you think of this and the move to this space in our surveys, which, as usual, we will collect at the end of the evening. And 2 lucky survey respondents will receive, will be able to win raffle tickets for drinks later tonight. So do your surveys. 2010 marks the 10th anniversary of the opening of this beautiful hall, the Rose Center for Earth and Space. In celebration, we are throwing open the doors of the universe to all of you, and I can think of no better cosmic guide through this universe than tonight's host. So it is with great honor and great pleasure that I introduce to you the director of the Hayden Planetarium, the great popularizer of science, Pluto's best frenemy, and the man who needs no introduction, Dr. Neil deGrasse Tyson.
This is a great turnout. I mean, this is supposed to be an intimate, you know, kind of coffee house sort of thing. So we had to like move it out of the, we had another room plan. So I want to try to at least keep it intimate. I don't know how, but we'll try, okay? Welcome to the universe here. I got to say it the way James Earl Jones says, welcome to the universe. You are here under this huge sphere. It is properly supported above your head. When we first thought of designing it, the natural thought was to support it from below. How else would you support a sphere? But views from the outside, it looked like a golf ball on a golf tee. We said, that's not cosmic. And so the architects figured how to support it from the sides so that you walk under the sphere as though you are in space. So welcome to the Hall of the Universe. And if you have a chance before the evening's over, you can actually find Pluto. It is a speck on that planet wall there at the bottom, grouped with other of its icy brethren in the outer solar system, the Kuiper Belt. That is where Pluto appears in this facility. 10 years ago, we were the first public institution to readjust Pluto's associations in the solar system, and we got in big trouble with the New York Times about that. But then the rest of the world caught on, and so now the hate mail has diminished significantly from third graders. They've gotten over it, and so should you, I think. This evening, this is a cafe. It's a big cafe, but it's a cafe, and I'd want this to be principally an open session where I will walk among you, you ask questions. I'll toss up a few other sort of current events-y kinds of things just to warm you up, but this will be driven by your curiosity, not by my curiosity, okay? We have playing behind me The Known Universe. It is our first YouTube video to go viral from this institution. You may have seen it. If not, you're not then among the 3.5 million people who have. It's a zoom out from the surface of the Earth out to the edge of the known universe, produced here in collaboration with the Rubin Museum of Art down in Chelsea for an exhibit that's now closed, sorry, an exhibit that studied the ancient concepts of Far Eastern concepts of cosmologies, but we felt to complete that story, you include modern cosmology as well. In the zoom out, now we're zooming back in. So this will play the whole night, give you something to look at if you're tired of looking at me. Just check it out, that's fine. So a couple of other current eventsy things. So you know Pluto's gone. It's still out there, but we have other relationships with it. We can talk about the past, present, future of NASA. We can talk about the black holes that were not made in the super collider in Switzerland. Many people thought the world would end. And speaking of ending of the world, there's 2012. There are people still a little worried about that. Anyone here dragged by their friend to this event this evening who themselves is still worried about 2012? Raise your hand. You could be honest. You're afraid to say that in this, the center of the universe. Okay, but we can straighten that out if you'd like. Other things, if you've forgotten what the latest is on dark matter, dark energy, black holes, this is the chance. And this is a bit of statistic that I've shared on some YouTube somewhere. If you haven't seen it, you will hear it now for the first time. There's about 6,500, 7,000 astrophysicists in the world. There's about 6.5, 7 billion people in the world. Divide those two numbers, what do you get? Thank you. Got Geek Row up here. He's got it. He's got the answer. 1 in a million. So, if you ever find yourself in the company of an astrophysicist, that's the time to ask all the questions you have, because you never know the next time that will happen, okay? This is one of those occasions, okay? We have someone here who will be pumping questions off from the Twitterverse. And intermittently we'll grab one off of Twitter. I tweet the universe daily. They're more like cosmic brain droppings. They're just sort of random thoughts that I had anyway, but it'd be a shame to keep them to myself. So earlier today, you might have missed it, I tweeted, actually, I'm adding some words because otherwise it's like a haiku. You wouldn't be able to understand it. So actually, America is inching its way towards the metric system. We're actually mostly metric. Okay, our money is metric. You never thought about that, did you? You're not paying for things in pounds and shillings, and our money is metric. Our engine displacement in cars is now metric. Plus, you have never in your life consumed a quart of Pepsi, have you? It's been liters, 2 liters, 3-liter bottles. Wine is metric. Health, oh, we have winos over here apparently. What you drinking? Let me find out. Wine is metric. The nutrition labels are metric. They tell you how much protein, carbohydrates, fat you're consuming in all of your food. That's metric. Photography is metric. The emergent field of ammunitions and bullets, that's metric too, but this is New York, so you shouldn't know about that. Anybody here from Texas? Right here. So we're inching along, and it's happening without anybody even taking notice. It's slow, but it's real, and I think it's irreversible. But anyhow, I'll go to the floor. There'll be a microphone roving. So what you'll have to do is hold your hand up sort of earlier so that they can find you with a microphone. We have one right there. Raise your hands. Yes, we have 2 high microphones there, and they'll come around to you as you raise your hand, and I'll just keep talking until you raise your hand and pose the question. By the way, you came in here for free, but it's a cash bar. I hope you didn't think you got free booze, by the way.
We've got our first question over
First
here.
question, yes.
Hi.
Hello.
I saw your interview.
This is my space here.
Okay.
So I will, and I'm an educator.
Okay.
So I will require that you don't start your question with the word Okay? Otherwise, you get docked a turn. Okay? So start again, and don't start with Okay? I know it's hard, but it's for the greater good, I assure you. Okay, go.
I saw.
Wasn't that hard? That was hard coming out of her. Okay, go.
I saw in your interview earlier with.
No,
with
ums in the
Times-
middle are okay. Just don't start your sentence with an
With Times Magazine, that you said he asked you.
Was this time 10 questions? The 10 questions interview?
Yeah.
Okay.
Yeah.
A reporter from Time Magazine came into my office and asked 10 questions submitted to the magazine, and then that was podcasted and is a little video of it. But the podcast has the full answer. The video is truncated so it doesn't bore you on YouTube. But continue, yes.
Okay. He asked you if you could go back in time, which scientist you would choose to speak with, and you said Sir Isaac Newton.
Oh, yes.
And I was just very moved by the way that you spoke about him, and you said that he just like really felt the universe, or he really understood it, and
Isaac Newton was in touch with the cosmos.
right. And you said that he.
But do you have a question, or you just want me to?
No,
Oh.
I was just.
You want me to share that with everyone?
Yeah, I just wanted to know.
You want to be moved a second time, is what you're saying. You were moved that first time, because I'll talk about Isaac Newton. Me and Newton go way back. Okay? Shall I?
Yeah, I wanted
Okay.
you to elaborate, because the way you said it, you said that he.
I will elaborate about Sir Isaac.
Okay.
I will do so.
Okay.
Isaac Newton. He didn't ask me what scientist would I see if I went back in time. He asked me, what person do I want to meet if I went back in time?
Right.
I said, it'll be the scientist, Isaac Newton. Isaac Newton, British scientist. He was a professor at University of Cambridge. He held the endowed chair that Stephen Hawking now holds, the Lucasian professor of mathematics. And he was a physicist. Today we would think of him as a physicist. Back then he was what's known as a natural philosopher who posed questions about the natural world as opposed to the human world. They're human philosophical questions, like the meaning of life and this sort of thing. Then they're natural philosophical questions. What is the origin of the universe and of the world? So Isaac Newton was brilliant. I own most of anything he's ever written. And I sit there and I read it. And as I read the sentences he put to page, hair goes up on the back. I don't actually have hair there, but I feel it. If it would, you feel like the goosebumpy kind of thing. If I had hair on my neck, it would be standing on edge as I see the depth to which he was connected to the operations of nature. There is no doubt about it. The man discovered the laws of gravity by sitting there. Okay, it's rumored that he sat under the apple tree, but what is certain is that he knew in the same field of view, he saw an apple drop and the moon in orbit around the earth. Okay, he sees the two of them. One is falling to the ground and the other is like up there in space. He connects the two and suggests that the same force of gravity is operating on both of them. They're both falling towards Earth. He hypothesizes, well, how's that possible? Because I can drop this camera on the ground, it would fall, okay? But if it's in orbit, it's not falling. But it is falling. It is. If you're in orbit, you are falling towards Earth. He drew a diagram to illustrate this. In fact, that diagram is on the wall over there called orbits. There's someone whose head is in front of the orbit now who's typing on his head. There's orbits. There's a whole orbit panel where we describe this, but I'll do it for you because I'm here in person. All right? He suggested, suppose you had a hill and you sort of fire a cannonball. not very fast. It would just kind of fall, right? Fire it a little faster. It goes farther before it hits the ground, doesn't it? Even faster, it'll go even farther. Now, wait a minute, Earth is curved. So if you keep this up, this thing is coming around the backside of the Earth. So he asked himself, there must be a speed sufficiently high so that that cannonball comes right back to the cannon. And all you have to do at that point is duck. And the cannonball ought to just slide on by and stay in orbit. The fact is the cannonball is falling every moment it's there. The difference is it's going sideways so fast that the amount that it has fallen is the same amount that the Earth's surface has curved away from it. That is the speed that gets you orbit. He figures this out. And that's why the moon is behaving the same way the apple is. The apple just doesn't happen to have sideways motion to bring it someplace other than right below. And when you are in free fall, you are weightless. That's the coolest thing to be. We have in our midst an astronaut. We have Tom Hendrick. Hendrick, where are you? Raise your hand. Please stand up. An official astronaut, okay? On several shuttle missions. So you got to admit, being weightless was cool. It's cool. Well, you got to put that on microphone.
It's cool, Neil.
There we go. And so he's in free fall around the Earth. Not only is the shuttle orbiter in free fall, everything in the orbiter is in free fall. So therefore, everything is weightless. Now, if you're in an elevator and you cut the elevator cable, up until the point you hit the bottom, you are weightless. You're in free fall. Here's an experiment you do. It's a very cool, cheap experiment. Take a tall glass of water in a paper cup. Make sure it's tall. One of those that Starbucks it'll cost you $8 to get it, but you'll get a tall cup. Fill it with water. Punch holes in the side. Obviously, the water's going to leak out. The water at the bottom hole will spew out farther than the water in holes higher, because the water weighs more above it. There's more pressure at the bottom to spray the water out. So the bottom one is far, and the higher ones are a little less. It's all because of water pressure, the weight of the water. Take that cup of water while it's spilling, drop it into a sink. It doesn't matter what you drop it into, but this is to minimize mess. Drop it. The instant it leaves your hand, it is weightless because it's in free fall. The cup is weightless, the water is weightless. And if the water has no weight, then the water does not know to exit the hole in the side of the cup that you punctured. So the instant you drop that cup, the water cuts off. It just stops. And the cup falls, hits the bottom, and spills in your sink. But while it fell, it is evidence that the water became weightless. The apple is weightless, the moon is weightless. That was Isaac Newton. On top of that, he discovers the laws of motion. Famous equation, F equals ma. You may remember that from high school physics or not. It's an important equation. You combine F equals ma and the laws of gravity, it gets us to the moon. It allows us to aim projectiles and land where we want on Mars. He also discovered the then known laws of optics. Put light through a prism, showed that white light is composed of colors. He named the colors of the rainbow. Roy G. Biv. Roy, you know Roy G. Biv? Roy G. Biv. Red, orange, yellow. Keep going.
Green. Blue.
Yeah.
Purple.
Indigo. Was there a P in Roy G. Biv's name? Actually, it's purple to some people, but to Isaac Newton, it was
Violet.
He left out the I.
Indigo.
Indigo. So he threw in, Isaac Newton had a mystical fascination with the number 7, and so there really, to most people, only 6 colors there. He threw in indigo. So, plus it spells Roy G. Biv. You can't give that up. So he puts these through, and here colors coming out of white light. This freaked out the artists, right? Because that's not how colors work in art. And then he took the colors, put them back together, got white light again. So he understood the behavior of light, of these different bands. And So came up with the laws of optics, laws of gravity, laws of motion, and on a dare, practically on a dare, he invented integral and differential calculus. On a dare. Somebody said, Ike, why do the planets orbit in this shape we call ellipses? An ellipse, a flattened circle. Why that shape? He said, you know, I don't know. It comes out of my equations, but I don't know why it's that shape and not some other. I'll get back to you. So he goes home for a couple of months, comes back, here's why it's that shape. Well, it's actually a cut from a cone. Take a cone and make cuts in it. You get an ellipse, a circle, a parabola, hyperbola. It's math people know this. This guy would know that who got the arithmetic good earlier, okay? So then the friend said, well, that's cool. How did you figure that out? Well, I invented calculus to find the answer. Most people are struggling with it just to learn it in school. He invents it for no other reason but a friend of him posed a challenging question. Isaac Newton, after all of this, then turned 26. I'm just saying. You read in the back of one of his books called Optics, where he discovers all his laws of optics. In the back, he has queries. These are like stuff he hadn't had the time to figure out yet. Maybe some others will find out. He says, I wonder if the stars in the night sky are just like the sun, except much, much farther away. It's like, yeah, it's like, okay. I mean, he's wondering stuff that became entire branches of study. The crumbs off his plate, all right, are the entire careers of other people. He then, later on, would die a virgin, okay? So just these are factors you might want to consider. I'm just saying, I'm just in disclosure. I just want to make sure you got all the facts. When I read Newton, I commune through time and feel connected to the cosmos. And I don't know if I moved you a second time in recounting this, but that's how I feel about Isaac Newton. I have a bust of his head on my, I have a table in my office, and there's a bust of his head there. Not his actual head, just it's a casting of his head. And he had that long hair before that was like fashionable for guys, you know, today. He had those curls, Newton curls. Okay, I took a long time answering that. Let me get your opinion. Should I spend a long time answering it if I got a lot of places to go in the answer, or do you want soundbite answers to get the most number? You like, even though I'll get to fewer of you, you're cool with that? Because I'll only flesh it out if there's flesh to give. All right? So we'll just track the microphones. Who's got the next one?
Oh, yeah.
Yes.
Hi.
Hi.
So a couple of weeks ago, scientists at Fermilab announced the results of an experiment in which they showed that in Big Bang-like explosions, matter is produced a slightly higher proportion than antimatter. And my question is, if the results had been just the opposite, if antimatter were produced preferentially by a little bit, could antimatter have created the universe that we live in now? And if so, would it be just like this, or would we be living in a bizarro-like universe?
Okay, so let's back up a little bit. We live in a world that's actually uncommon for what goes on routinely in the universe. If you go to the center of the sun, for example, I don't recommend this, but if you went to the center of the sun and you managed to not get vaporized, you would find that the light that is passing your head, it's primarily X-rays, a little bit of gamma rays, it's mostly X-rays. There's other light too, but it's dominated by X-rays. X-rays is just another band of light. Isaac Newton didn't know that. He didn't know everything. All right? The whole spectrum. We have Roy G. Biv on the other side of the V. We have ultraviolet, invisible to our eyes. We can detect it, though. You detect it by, you detect it by your sunburn. You detect it a little too late. See, it's a time delay there. And then you really detect it with skin cancer. See, so you want to, beyond ultraviolet, you have X-rays, and that we can't detect those either. And then gamma rays. You could eventually detect these, but again, we detect them with cancers and things. It's not an effective way to detect it. Go to the other side of red, we find infrared. Can't see that either. Beyond that, we have microwaves and then radio waves. All of it is light. It all travels at the speed of light. So if you go into the sun, here are these X-rays. They have such energy. These are photons of light. They have so much energy. Energy goes up with violet, ultraviolet X-rays, gamma rays. It goes up. It goes down in the other direction. It has so much energy that you can ask, what happens if you plug that energy into the equation E equals mc squared? Just do that. If that's the energy on the left, what mass equivalent is that? And you know what you find out? It has so much energy, it could spontaneously make matter. It can make a pair of electrons on its own. So in the center of the sun, matter is being forged out of the soup of energy every moment of the sun's life. Now, what kind of matter does it make? It makes an electron and an anti-electron, a positron. Matter and antimatter pair. Antimatter is real. We invented it, not the science fiction writers. I know they've taken command of it, but it's our idea. We got to get credit when we can, because the science fiction writers can be so good at this. So when you have a high enough energy for the light, it will spontaneously become matter, and the matter-antimatter pair come back together. It makes the X-rays again. It's a soup. That's unfamiliar to us. We don't see that. Visible light doesn't do that. It's not energetic enough. It just stays as light or gets absorbed, but doesn't become energy. It doesn't become particles. All right? In the early universe, this went on big time. Big time. And it's one of the symmetry laws of particle physics that light becomes two particles, matter and antimatter. You bring them together, they become light again. It's always symmetric. Always. Yet, we're made of matter. Where's the antimatter? So there's some discussions that if an alien came and landed from another galaxy, before you shake its hand, or whatever appendage it's offering you, flip it a coin. If the alien spontaneously explodes, it's antimatter. Just always be ready to have something else touch the alien. So antimatter are perfect counterparts to matter. So something happened in the early universe to create an asymmetry. It's one of the mysteries of the early universe. 1 out of 100 million of these particle-antiparticle pairs, 1 out of 100 million of them was just a particle and not the antiparticle. 100 million. I mean, it's rare, but it happened enough to account for all the matter that we know and see and love in the universe. There's no reason to think that if it happened the other way, that we would just be antimatter talking about matter aliens, flipping them an antimatter penny. But then they probably wouldn't call themselves anti-anything, right? So yes, it's one of the great mysteries in the early universe, how it came to be that there's an asymmetry in this very symmetric process that we see all the time. So that's a long answer, but you get the full context of that. And it affects the Big Bang as well as what's going on in the center of the sun. And technically it would be called symmetry breaking, more broadly. You can Google wiki symmetry breaking, and they talk about the laws of physics that are broken by some phenomenon or process in the early universe. Who's got the microphone?
We have another question over here.
Oh, you have to be more triangulating on ear. Oh, there we go. Thank you.
I hope this isn't too off topic. Sorry.
This is the universe. How
well,
could it possibly
this is in the
be
universe.
off topic?
Then this is in the universe because
As long
I don't
as
know
it's
when
in the universe.
I don't know when I'll have an astrophysicist to ask this of again.
Mm-hmm.
So in light of current events involving the BP oil spill, and
oh, by the
something
way,
that I read in the
by the way,
yeah,
everyone blames BP, but it's our oil spill.
The oil spill that's
We all
currently a
use
disaster
oil.
in our world
We
right
all
now.
fill our cars.
Okay.
We are collectively,
Without a doubt.
Okay.
So, in light of that and something that I read in the Times on Sunday saying that we know more about deep space than we do about the deep sea.
Indeed.
Would you suggest that perhaps we should spend more time studying things that we don't know in our world? And as an astrophysicist, can you suggest anything that might be done that they are not trying?
Okay, so there are two questions there. How do we help BP fix the problem? And should we spend more money on Earth than in space? But you link them into the same question. That's awesome that you managed to do that. I only had one suggestion for BP, and I tweeted this a couple of days ago. I said, what's all this effort trying to plug the hole? It's coming out of the ground. Ultimately, that's what we want the oil to do anyway, right? Why don't we like put another pipe and fill a barge with it? So I just tweeted that because it seemed to me to be easier. Then I later learned that they tried that, but that failed. But that's got to be easier than trying to stop the leak. Just to can't you just put a thing, just okay, and I got it coming here. I mean, you do this as a kid, right? You put pieces of things together, and you finally get one, you put it in a barge. We need the oil later on anyway. We probably need it right now, all right? So I don't understand why that wasn't the first thought. One of my concerns about this failure is that it's actually an engineering failure. And if you create a world absent of engineers, because all the smart people who would have become engineers had no grand plans to go into as a job. In the 1960s, we were going to the moon. Even though it was a militarily driven enterprise, it attracted scientists, engineers, mathematicians to want to become those fields. When there's a disaster that happens, I don't want people saying, oh, we plug it with golf balls. Like, what kind of solution is that? Like, where is the genius that we know the human mind is capable of? Well, I think they all became investment bankers or lawyers. They're not scientists and engineers. So the fewer scientists and engineers in your midst, the more susceptible you are to the failure of your infrastructure, because you don't have people thinking about how to prevent it in the first place. For example, the day we find the asteroid is coming. Oh, by there is one coming. If there's time, we'll get to it. But, okay. But just if there's time, I don't know, we might. So, we got, so the asteroid's coming. Most people, you know what they'll do? They'll say, run! Stockpile food! You know, they'll say, okay, that's not who I want sitting next to me. The person I want next to me saying, how can we deflect that? That's a different brain. That's a brain that sees a natural disaster as a problem to be solved, not as a disaster to run away from. And if you don't have engineers, no one is thinking that. Nobody. They're just thinking how to run away from the problem. That's a problem in our modern society. So now, getting back to spending money on Earth and not in space. That's a common criticism of NASA, actually. Why are we spending money up there when we got perfectly good problems down here to solve? And I understand, I hear that. It's not that I don't hear that question, but it's missing some context. Some context. For example, did you know that global climate change did not exist as an understood problem on Earth until we studied the effects, when I say we, I mean not me, we, the community, studied the effects of the asteroid impact that took out the dinosaurs 65 million years ago. There's a whole portfolio of reasons everybody's giving for what killed the dinosaurs. Then we find a 200-mile diameter crater off the Yucatan Peninsula in what is now Mexico, dated to 65 million years ago when all the dinosaurs croaked. I'm saying we got an asteroid took out the dinosaurs. You're going to talk about it was cold or they had a virus. I got an asteroid, okay? So that forced people to ask, well, if you weren't in the 200-mile diameter, where we know you're toast, how might you have died around the Earth? So you look at the fires that would have been created. You look at the Earth's crust cast into the atmosphere. You notice that it cloaks Earth, blocking sunlight from reaching the photosynthetic plants. if you take out the base of the food chain, then a wave of extinction percolates across the tree of life. We learned about this, and this forced the climate models to understand global climate in a way no one ever had the occasion to think of before. That's when it was born. Not because somebody was looking down, I got the solution here, I'm looking down, I'll figure it out. No, sometimes you have to look up. Do you know that planet-wide greenhouse effect was first discovered on Venus? Venus has a really bad greenhouse effect. It's 900 degrees Fahrenheit on Venus. And I did the math. You could cook. You okay over there? Okay, okay. Sound like she was planning to visit Venus, and now she's got to cancel the vacation plans. Venus saw it. You could take a 16-inch pepperoni pizza, put it on the windowsill, and it will cook in 9 seconds. Okay? That's hot. You would vaporize as well. So this is a thought experiment. If you could do this, so global greenhouse effect. It was understood there before we could then bring it to Earth. Earth is not some island in the middle of nowhere. It is connected to the cosmos. And no science can claim an understanding of its subject if its subject is numbered only 1. You need multiple objects to compare and contrast. That's how you learn. What is special, what is not special, what is real, what the phenomena are. And so to say, let's only spend the money here, that's suicide. Not only that, how much does NASA get? I've done this experiment. I ask people, those that say, why are we spending, these people, okay? And so how much do you think NASA's getting? Here's your tax dollar, pull out $1, here's your tax dollar. How much are they getting? Okay, and here we go. Got my $1. Oops, that's a 5, wait a minute. Oops, that's another 5. There we go, $1, tax dollar. How much? Here's your tax dollar. Is it 10 cents, 20 cents, 30 cents? How much is NASA getting? It is getting 1/2 of 1 penny of this tax dollar. 1/200th. That's not even, you're not even in the ink yet. Here, you're in the edge. That pays for the rovers, the space station, the space shuttles, the Hubble telescope, all the NASA centers, NASA headquarters, all of that. And I ask you, how much is the universe worth to you? Okay. Let's get a question from the Twitterverse. Where's my Twitterverse list?
We've got a Twitter question over here.
You can pick the question.
Oh!
She put an in front of every Twitter question.
I'm joking, Dr. Tyson.
Mm-hmm.
So a tweet from Focal Matter. When will
Focal Matter?
Focal Matter.
That sounds like a geek tweet is coming right there.
When will mankind see interplanetary travel?
That sounds like a deeper question than it actually is. I mean, when are we going to Mars? That's what that is. Unless you meant interstellar travel. Interplanetary. We're not going to Venus. All right? I ain't going. If you're going, you ain't coming back. All right? It's one of those one-way trips. Mars is the only other sensible planet we could possibly visit. And in the current NASA budget, which is actually increased from previous years under the Obama administration, it has plans to develop what we call heavy lift vehicles. Heavy lift would enable you to not only reach orbit, as current launch vehicles do, but to go beyond low Earth orbit like we did back in 1972. And those vehicles, you'd be able to scale them in such a way so that they would get us to Mars, beyond the moon onto Mars. If that all goes well, surely before mid-century. And one of my concerns, however, is the motivation for going into space. If it's not clearly defined, it may never happen. In the 1960s, we told ourselves we're discoverers, we're Americans, we explore. Meanwhile, the subtext was we're at war with the commies, right? And it was like beat the commies to space, right? That's really what that flow of monies was doing. And so if we want to go to Mars, if there's, I don't believe the nation can rally around the simple quest to explore. The history of human civilization does not support that. But what does support is the urge to get rich. So we find like oil on Mars. We'll be there like next week. Where we find rockets will be there. So I'd say by 2050. Another question. We got to go where the microphones are. Okay.
This side of the room? Crater side?
This, I need more. Crater side. Thank you. Yes. Where are we?
At your Beyond Belief 2006 lecture, you said that...
Were you there, or did you watch the YouTube?
I watched the YouTube.
Okay.
You said that what stopped Middle Eastern scientific progress was a theological takeover.
Yes.
Do you think that's happening?
That's a shorthand for what I said, but yeah, I built the case a little more elegantly than that.
It was much nicer, yes. Do you think that's happening here in light of what's happening with like scientific textbooks in Texas and things like that?
Yeah, I just read recently about the plight of textbooks in Texas. I spent some time in Texas, 6 years actually, and of course Texas has Johnson Space Center. These are the folks who track everything we put in orbit with humans on it after it passes the launch tower in Cape Canaveral. All command goes over to Houston. So Texas is a fundamental part of our space enterprise, culturally and historically. So that for them to now have textbooks where the science content is altered to be different from what is going on in mainstream science worries me greatly. What you're referring to in the talk that I gave at that lecture was in San Diego, 2006. It referenced what was going on 1,000 years ago. 1,000 years ago, the intellectual center of the world was Baghdad. Baghdad. Europe was busy disemboweling heretics at the time. Baghdad was open to all thought at the time, between AD 800 and 1100, around there. If you look at the advances that unfolded in that period, in that location, it includes the invention of algebra. Algebra is an Arabic word. Algorithm is an Arabic word. 2/3 of the stars in the night sky that have names have Arabic names. How does that happen? Just where did the naming rights come from? It came from the fact that at that time, huge advances in the Middle East, in Baghdad in particular, was unfolded in engineering, mathematics, especially mathematics, astronomy, navigation, physiology. And you say, well, why is that so? If you look at what was going on, they were open to all lines of thought. Jews, Muslims, Christians. There were doubters back then. Today we would call them atheists. They would all come around a table and share ideas. If you have some philosophy that's got holes in it, someone's going to find it. And you're going to challenge you on those ideas. And what happens is the conversation ratchets up. You discard what doesn't work and you keep what does. And when you do that, you make discoveries, and you make discoveries rapidly. And at the time, that period drew to a close. If you read history books, they'll typically describe sort of the sacking of Baghdad. It was a bad time for the city. And they say, oh, it all came to an end. However, the Islamic culture rose at other times later. And in those other times, science and engineering discoveries were not a part of it. So he asked, why not? You got the cultural heritage, why doesn't it show up again? And then you got to dig a little deeper from the sacking of Baghdad, and you find out there was a Muslim cleric, Al-Ghazali was his name, who was to Islam what St. Augustine was to Christianity. St. Augustine kind of laid out the rules for how to be a good Christian at the time. A lot of people were practicing it in their own way. He codified it. He was a religious scholar, figured it out according to his own read, told everybody how to behave. There's the book. You follow this, you're a good Christian. Al-Ghazali said, you follow this, you're a good Muslim. In that text included the assertion, which gained influence socially, but then politically, so then it had power of influence. In there was the assertion that mathematics and the manipulation of numbers was the work of the devil. The entire enterprise collapsed and never recovered. It has not recovered since. if you look at the number of Muslims who have won the Nobel Prize in the sciences, it's 1. Number of Jews who have won the Nobel Prize, 1/4 of all Nobel Prizes in science have been won by Jews. How many Muslims in the world? 1.3 billion. How many Jews in the world? 15 million tops. So you look at what effect the culture of discovery and learning can have on what you discover about the natural world. It's extraordinary. So just because you're making discoveries doesn't mean it's forever. And I look at the 20th century in America as a period of great discovery. And then I see forces now operating against it. And then I look at the history of the consequences of this, and I see America just simply fading into insignificance. No, it's not off of a cliff. It's just a slope. And every next day you're a little bit further down on the slope. You barely notice it, right? Until one day you can't see over the hill that you just came from. And then you try to make do with what you have down here, and then you find out it's the rest of the world making the inventions and not you. You're trailing, no longer leading. You're not even abreast with what's going on. You're running behind trying to catch up. Have a nice day. Yes.
We've got a question right here.
Another question, yes.
Sir, part of the...
Look how many pens you got in your pocket. I smell geek. How many pens you got? 1, 2, 3, 4, 5, 6, 7, 8, 9. We got a geek right here in our midst. Raise your hand. Give him a hand.
What you have is a 70-year-old questioner.
Okay, go for it.
Part of the basis for the Big Bang Theory is the redshift that occurs as the galaxies accelerate away from us. How do you distinguish that redshift from that which would occur from the aging of those that are older because they were born first? 1. And 2, because there is this Big Bang Theory, you should be able to calculate the trajectories of all the galaxies and figure out where the center was. Can that be done?
Excellent questions. So the first one, yes, for those who have been living under a rock, we live in an expanding universe. We know this because we look out to the universe, we see galaxies, and in a discovery made by Hubble, Edwin Hubble, back in 1929, it was first published, he noted, whether there are people behind the meteorite here, I'll look at you every now and then here, but I can't. Hi. All right. I'm thinking about you. I'm thinking about you. But this is really cool to look at. Oh, and by the way, right there, this is where Stephen Colbert licked it, right in that spot, okay? Just so you know. Stephen Colbert visited the Rose Center one afternoon, worried that his comedy talk show host job would be in jeopardy, and he wanted a fallback job as an astrophysicist. So he had me train him to be an astrophysicist that afternoon. And so I showed him the meteorite, and he just decided to lick it. And then I said, that's the oldest thing your tongue has ever touched. At 5 billion years old, he said, no, I once had Jane Fonda on my show. And so that was like, whoa, where'd that come from? Then I dug up a YouTube clip, and Jane Fonda is on the show, and she saunters around the table, sits in his lap, and tongue kisses him. So this is like in his head when that was happening. So, but I digress. Jane Fonda and the Big Bang in the same sentence here. So we see the galaxies, and Hubble noticed this. He used data provided to him by others, and Huminson and Slipher, two very brilliant experimentalists. In the astronomical world, we call them observers. So they look at the galaxies, and you find out that the spectrum, credit Isaac Newton, the spectrum, there are features in a spectrum that we attribute to various chemical elements. Carbon has a fingerprint revealed in a spectrum. Oxygen has a separate fingerprint. I use the fingerprint almost literally here. Every element has its own signature in the spectrum. So you know what the pattern of lines of features looks like on Earth. You look at the galaxy, you find that same pattern, but it's shifted. You say, well, how much does it shift? That means the galaxy is moving away from us. We learned this from Christian Doppler, a German physicist in the 1800s. He did an experiment with a train, okay? And so what happens? The train whistle goes by. We know this intuitively, even if you've never thought it. It doesn't go, well, let's do it with a race car, because I can make that sound better. The car goes Right? Did I get it right? That's pretty good, right? Right? Okay, I can do that better than a train. All right. So, the car does not go. It doesn't do that, does it? No. It doesn't go. No, it doesn't do any of that. It goes high pitch to low pitch. So the sound waves up front, every sound wave it makes, it now travels closer to that sound wave before it makes the next wave. So the pitch, so the wavelength is shorter, the pitch is higher. Okay? And when it recedes, the sound waves get stretched apart. You get a lower pitch. So analogizing what we see in the universe, you can conclude, I'm getting there, you can conclude that the galaxies that show the shift to longer wavelengths of light are moving away from us. They indeed were. He then noticed that if you were twice as far away, the object was moving twice as fast. And he looked in every direction and found, like we had some kind of case of cosmic BO or something, all the galaxies were scattering away from us, all except for a couple that are really nearby, like the Andromeda Galaxy, which we will collide with in a few billion years. More on that later. So, if you're interested, we'll get the meteorite before that, because that'll be more important. So it later turns out, Einstein shows us, that this redshift is not specifically a Doppler shift, it's what we call a cosmological redshift. It shifts because space itself is expanding. And so the wave, as it moves through space, gets stretched in the expansion, the fabric of space and time itself. And so, if everybody's moving away, turn the clock back, you can ask the question, when was it all in the same place at the same time? That was 14 billion years ago. That's how we date the Big Bang. We look around, turn the clock back. And which way is everybody going? Back to the same spot. It looks like we're at the center. But the signature of this expansion would be revealed no matter where you are. If you go to this other galaxy over here, this expanding fabric of the universe will look like it's centered on this galaxy as well. So everybody was at the center 14 billion years ago. There's not some center somewhere else. We all occupied it in a different state at the same time, at the same place, 14 billion years ago. Did I answer both questions? Oh, aging, yes. So how do we know this shift is not because the thing's getting older? Because if you're getting older, you might have some red stars in there. It doesn't actually shift the lines. You can change the color, but without shifting the pattern of lines. That's why we look at the fingerprint. Fingerprint is here, there, or there. You got it. And you know it's not something else going on. Let's get another Twitterverse question. You got one? And now you can start with and we'll know you're just messing with me. Let's hear a good
Dr. Tyson.
Okay.
Dr. Tyson. This is a tweet from the Aura.
The Aura, okay.
What percentage of outer space is estimated to have been observed, and what is estimated that can be observed?
Okay, there are parts of the universe that are blocked from our view because we live in a pancake. A pancake. So imagine you're a blueberry in a pancake. Now, most blueberries are slightly wider than the width of your pancake, most. So they sort of punch out above and below. Our galaxy is like the pancake. We are like the blueberry. If you want to see the rest of the universe, you have to look above and below the pancake, because otherwise the pancake itself is in the way. So all the data we have on this universe comes to us from looking above our flattened Milky Way galaxy and below it. All the data we have on cosmology and the like. And so, in the known universe, in fact, there is a part where since we're only showing you the known universe, it means where there isn't a known universe, you get to see the unknown universe. It's the absence of the known universe. And so I will monitor it and I'll show you the cut through the sky where we don't yet have deep data on the universe because we're stuck inside of a dense disk of clouds of gas and dust that prevents view from outside. So here we are rising from the Himalayas. Oh, you guys can't see. So I'll describe it for you. We are now elevating above Earth. We now get to see how thin Earth's atmosphere is. If Earth were a schoolroom globe, shrunk to that size, then Earth's atmosphere would be the thickness of the lacquer on that schoolroom globe. Yet we think of it as this huge ocean of air, but it is in fact not. And if Earth were a schoolroom globe, the moon would be 30 feet away. Mars would be a mile away. The space station and space shuttle would be orbiting 3/8 of an inch above its surface. NASA tells us that that's going into space. That's boldly going now where hundreds have gone before, is what that is. So we are still ascending from Earth. It's a slow ascent. Actually, it'll be a while before we get, at least a minute or two, before we get to the edge of the known universe there. So there are sections. So I would say we have mapped to the edge of the universe. We have looked in, I would say, 80% of the universe. We're not given reason to think that if we could look in those blocked zones, that it would be fundamentally different from the other 80%. So nobody's really worried that they're like gremlins on the other side of this zone. And by the way, and for a while that was known as the zone of avoidance, because we didn't see any galaxies in that band. But it's not that the galaxies were avoiding it, it's that they were simply not visible to us. You can see the cloudy band, that is the Milky Way. Milky Way is not visible from New York City, but it is up there. It's visible from the Hayden sphere above us. If you come to one of our celestial highlights evenings, you'll get to see the night sky. And so there's the galaxy in view. We're about to, I'm giving you play-by-play, you guys who are behind the screen. And we're still zooming out. Eventually, the constellations will distort. People think constellations are real things with real, it's just this pattern that you happen to see from Earth. And we're still expanding out. Now, here we go. That's the radio bubble. That edge of that bubble has like Howdy Doody radio show on it. And so there's our galaxy, the Milky Way. And so now you'll see data. Now you'll see these empty spots in the data. Just watch as the nearby galaxies come into view. You will see these almost. Give it a chance. Here we come. Now, take a look at these two swaths above and below. It looks like a butterfly diagram. Those two swaths are sight lines unavailable to us because our own freaking galaxy is in the way. Okay? So I'd give it about 80% of the universe. Other questions? Who's got the mic
There's
next?
only time for a few more questions.
Oh my goodness, okay.
This one's from behind the meteorite.
Behind the meteorite. Oh, you guys do have your voice.
This, Tyson, is for you personally.
Me personally, sure.
What point in your life was it that you became like, this is what I want to do? I grew up with a very affluent family, and they were like, okay, let's just check out, astrophysics was a very big part of my life growing up. And you get to a point, like Carl Sagan was, to me almost a god as a younger guy. And growing up like you've brought back like the passion, that's in there. And it's kind of something that's been lost for, almost 2 decades. At what point in your life where was it like, this is it, and this is what I want to be? I mean, you've brought back a lot of the passion to it that's kind of been missing for a very long time.
Well, thank you. I would say that the passion, I almost can't control it. It's that, like the universe is, when was it? I was 9 years old. Where was I? In the dome of the Hayden Planetarium. How did I get there? My parents took me, my brother, and my sister on another weekend trip to the cultural offerings of the city. If it wasn't here, it would have been at the art museum or at the plays or even operas and weird stuff that if you're 10 years old, it's just kind of weird. But we got that exposure. And there I am. I'm in the dome. I'm looking up. The lights dim. The stars come out. And I grew up in the Bronx. And in the Bronx, we say, we got Bronx in the house, apparently. In the Bronx, we say, the Bronx. All right. So I'm there. The stars come out. And I say, oh, that's charming, That's an interesting hoax. There aren't that many stars in the night sky. I've seen all 8 of them from the Bronx. I know. All right, there's a lie, but I'll go along with it anyway, just to humor them. And I'm there, and then that voice comes over, that planetarium voice. That's the next thing to God you'll ever hear, is the planetarium director's voice coming out of the sky, all right? And we now move to the looking east into the setting sun. You know, it's like, so you're there, right? And at that point, it's as though I had no choice in the matter, and the universe called me. And from then on, I knew there was something really cool about the universe. It would take 2 years till I was 11 to know that it could be a career. At 9, you're not saying, well, how am I going to make money? You're not thinking that. 11, I knew enough that it was time to direct my life in such a way for it to become a career. And so, thenceforth, I started taking extra classes here at the Hayden Planetarium. I still have certificates of graduating from those classes signed by the director at that time. When I became director, I swore that I would try to have the influence on others that the educators and scientists back then had on me. And until just recently, until we shifted our programmatic offerings, I signed those certificates of those who had graduated from the courses, just as the director had signed my certificates. And I signed them with my pocket full of pens, all right? So that's how and that's why. And as Carl Sagan said, when you're in love, you got to tell the world. And so it's not a hard bug to catch. It's pretty easy to catch. And everyone I know who's caught it, they're off, they're doing it. And in fact, when I was a kid, I thought, I don't want to be an astrophysicist because everyone will want to be an. If they knew this, they'd all want to be it, and there'd be no jobs. You know, I had that thought, a crazy thought. Then I found out, no, most people actually don't care. You know, maybe that can change. Let's take a few more questions. I'm amazed time went so quickly. The lady who wants to go to Venus, yes.
Funny.
You're the one who squealed when I talk about cooking a pepperoni pizza.
Well, that's because I'm only 29, so
Okay.
you know. Here's my question. The future of NASA is a big concern for those of us who kind of believe in the preservation of our planet and the world in which we live. Can you elaborate on what the status is with that? And then can you talk about that little old asteroid that's
she wants to with the asteroid. Okay, so NASA, right now there's a political battle going on in Congress regarding what happens over the next several years with NASA. The Obama plan, as it was put forth, would shift emphasis from the kind of launch vehicles that served the shuttle to the kind of launch vehicles that would serve a trip to Mars, bypassing the moon. Meanwhile, there's a huge industry built up that serves the shuttle. Meanwhile, there's a whole community of people who want to go back to the moon. I would even count myself among those. My next trip out of low Earth orbit, I don't want that to be a 4-year journey. I want to remind myself how to do this. And the moon is 3 days away. You can do that in a news cycle, right? You can get there and back, check the engines, you know, kick the tires, make sure everything's working. So, but I don't jump in the middle of that debate. I actually celebrate, because I try to be stratospheric here. I'd rather celebrate the fact that we have the luxury to argue over what NASA's next destination would be, rather than worry about NASA's budget at all. So I think it's actually a happy time that we're having these debates in Congress, and you know, putting Neil Armstrong against the next generation entrepreneurs, and so there's some jockeying going on. But I don't get in the middle of those fights. So the concern is if we break our manned presence in space for 5 years, maybe it'll never come back at all. That's always a risk. You cut a budget in the government and something else happens, some other priority comes up, it's easy to never bring it back again. Do you know the pyramids in Egypt? They stopped building pyramids. I don't know if they ran out of pharaohs to build pyramids to, or they ran out of money. One day they stopped. Do you know the pyramid, the top of the tallest pyramid? Do you know what year we built something taller than that pyramid after that pyramid was built? Anybody know? It was in the Paris Expo. The Eiffel Tower was the first object we ever built as a species taller than the pyramids. So just because you're doing something in one period of time doesn't mean it will continue forever. In fact, one of my great fears is that you end up taking it for granted because it's around you all the time and you forget what investment a previous generation made in it. You just coast. What you don't realize is that you're coasting downhill. And you end up, like I said, no longer being able to see above where you needed. So there's some people worried about that gap. I'm a little more confident. I know people working within the Obama administration, and I've met him. He seems sincere to me. Even factoring in the charisma, even subtracting that out, because that'll be no matter what he tells you. You know, there's charisma there. So I got a filter for that, all right? So you filter that, is it still real? And I got the sense that it's still real, but we'll see. We've got to see how that goes. And your next question was, oh, the asteroid. Oh, you're worried about the asteroid. Oh, wimp. Well, there is an asteroid headed our way. By the way, I'm on YouTube describing this. And who here has not seen that YouTube video? Really? Okay. So I'll give you a version. This will be a live YouTube version of it, okay? Okay, okay. So, December 2004. In fact, I may have to end on this question because I'm going to flesh it out in ways that there's no way another question can follow it. Okay. So, December 2004. We discover, again, it's my community. I'm not out there. I'm occasionally out there, but most of the time when I say we, it's not me. It's just we, the astrophysicists. December 2004. We discover an asteroid. We have a couple of data points on its position in the sky. You look at its speed, you get a Doppler shift on it. You get its direction, you plug it into the computer. There was some 20% chance it was going to hit Earth on April 13th, 2036. Did you hear about this asteroid when it was discovered? No, because that same week was the Indonesian tsunami. That same week. And so rightly so, it did not lead the headlines the way the tsunami did. However, if you did the calculation, you would show that if it hit Earth in the center of the uncertainty range, it would hit the Pacific Ocean 500 kilometers west of Santa Monica. It would plunge into the ocean to a depth of 3 miles. It would explode at that depth, cavitating the ocean in a hole 3 miles wide. Now you have a wall of water 3 miles high. What happens to that wall of water? It just spills back into the hole that was just made, splashes into itself, and rises high again. That first impact creates a tsunami that's 5 stories tall. By the way, this asteroid is the size of the Rose Bowl. In other words, it would fit neatly in the Rose Bowl the way an egg does in an egg cup. So, So, here's the first wave. The first wave is just from that first impact. You cavitate the ocean, it fills up again, rises high into the stratosphere, falls back, cavitates the ocean again. Now it's water cavitating the ocean, not the asteroid. That sends another wave, and this repeats. Calculations show this will repeat about 40 times. 40 times. 40 tsunamis, one right after another. What's interesting to me is that tsunami would take out the entire west coast of the United States, do $10 trillion in damage. It would make the Indonesian tsunami look like a slightly overflooding puddle. So it was a lost opportunity to compare and contrast magnitudes of disaster. It would later make the news when better data became available. But let me explain this tsunami to you. So it's a wall of water 5 stories tall. The next tsunami, 40 seconds later, because it would be pulsed every 40 to 50 seconds, the next tsunami needs that water. There's not an unlimited supply of water. The first wave has got some of the water that the second tsunami wants to use. So what happens? The first tsunami goes in only as far. It goes 40 seconds into land. Then it's pulled, 20 seconds into land, 20 seconds back for the next tsunami. So in fact, if you do the calculation, you can show the tsunami would not go past about a quarter mile inland. You could set up a rope, you know, like one of those club ropes, and just sit there and just watch the whole thing happen. The waves come in, they pass through the multi-million-dollar Malibu homes. The wave comes out, brings the home with it. Next wave comes, takes the home back in a slightly different shape than it was before. This process basically ablates the entire west coast of the United States. We would know this in advance, thanks to Isaac Newton and his 2 equations he developed as a 26-year-old virgin. And so, so actually nobody has to die. It'll still do the $10 trillion in damage, but nobody, we know this in advance. But I thought about it, there are 2 people who will die. 2 people. And you know who they are, okay? There's the idiot surfer who wants to get that last wave. You know, rad, man, I'm gonna, you know, the idiot surfer. We got 1 dead surfer and 1 dead weatherman. You know the weatherman, trying to get the camera closer to the hurricane. Come, you look at the waves crashing on the shore, you know, and the cameraman keeps backing up and he pulls him in. 1 dead weatherman, 2 dead people, right? That's what you get. So a little later we would get better data. Once you discover an asteroid and you know its trajectory, you could look in historical photos for where it would have been in the past if you got your trajectory right. Then that becomes useful data to you. It's called a pre-discovery photo. It's common in my field. Once you have a general direction that something's going in, you just turn the clock back. Once we dug up pre-discovery photos and got some better data later, we were able to tune what was going to happen. So here's what will happen. On April 13th, in the year 2029, that's 1 orbit away from the 2036 date. It has a 7-year intersection orbit with Earth. On that date, April 13th, which, by the way, is a Friday. So April 13th, 2029, this asteroid named Apophis, named for the Egyptian god of death and darkness. Named, of course, only after we calculated its trajectory to intersect Earth. If it were not going to hit Earth, we could have named it like Bambi or Tiffany, something non-threatening, right? Freddy, you know, something that, no, it's not hurting anybody. Name that one Apophis. So, we know for certain that Apophis, on Friday the 13th, April 2029, it's the size of the Rose Bowl, it'll get close enough to Earth that it will dip below Earth's communication satellites. It'll be the biggest, closest thing ever to come, known to come near Earth. The communication satellites are at geosynchronous orbit. It's about 23,000 miles up. This will come in at 18,000 miles. It'll be visible from northern Europe. The Geek set has already rented the hotel rooms there, so you're out of luck, because they did the math and they knew when and where it was going to happen. It'll look like just a fast-moving, bright object across the night sky, moving at about what speed do I give it? Probably around 10 miles per second. That's hauling. That's fast. So here's the catch. Its orbit remains sufficiently uncertain. Let me back up. In the possible range of orbits it could have on that fateful day, there is an interval range where if it threads that keyhole, we call it a keyhole. It's a 700-mile range. If its orbit goes through that range, Earth's gravity will be just right. Or rather, just wrong. All right? So that it will alter its orbit so that it will hit us 7 years later. So the test is it going to go through the keyhole? The latest estimates are that the likelihood, with updated data, is that the likelihood that it'll go through the keyhole is several in a million. Much better for us than the 30% first estimate, or the 1 in 42,000 estimate that had been around for a couple of years. So you say, oh, not a problem. There are people who bet on the lottery with worse odds than that, expecting that they're going to win. Would you put $10 trillion in harm's way? Actually, if any insurance people here, I know there's got to be, you just do the math, right? $10 trillion divided by the probability of it hitting, spread that among the total population of the West Coast, and you have an insurance policy. That's how that works, right? That's how you calculate insurance policies. Oh, by the way, I think I saw Steve Soda here, my colleague. Steve Soda, we've collaborated on all the exhibits here in the Rose Center 10 years ago on our anniversary. Steve, could you remind me who of the famous astronomers of the past actually invented actuarial tables? Sir Edmund Halley invented the notion that you can calculate a risk using actuarial tables. An astronomer did this, okay? So it's good to have people who think about the universe. Who here only wanted to look at Earth? Where did she go? Where's my Earth woman? Did she leave? Yeah. Oh, she's still here? Oh, yeah, you're sneaking out over here on me. You're the one that only wanted to look at Earth. People who look up, like, also invent stuff. Just want you to know. Okay? So, the problem is so we don't know the orbit well enough to say whether or not it's going to go through the keyhole. We need better data on its location in space. So what we really want to do, and in fact one of the plans of NASA's next voyages, is to visit an asteroid. Why not visit the asteroid that has our name on it? The one that's headed this way. Just call Bruce Willis. You know, that's all you got. That's all you got to do. Put him on your speed dial. Say, Bruce. No, we need Bruce Willis for the oil leak in the bottom of the thing right now. Then we'd send him into space. He was an oil rig driller, if you remember from Armageddon. That movie was made with a whole other universe of laws of physics, just so you know. Not from this universe. That's why no aliens made that movie. So where was I before I distracted myself? Oh, visit, yeah. So here's what you do. You go to the asteroid, and then you stick LoJack on it, okay? Something where it's telling us where it is to like 1 centimeter per second accuracy, okay? And its velocity and its location with that accuracy. Then you put it back into the equations, you sharpen the orbit, you reduce the uncertainty, and you'll know whether it'll go through the keyhole or not. If it's targeted to go through the keyhole, all you have to do, well, if you're like military generals who know you got like nukes in the silo, you blow the sucker out of the sky. You know, we got those folks. We know who they are. The people who want to blow stuff up. Problem here in America is that we're really good at blowing stuff up and less good at knowing where the pieces go afterwards. We're just less good at that, all right? So I don't want to blow up Apophis. Then we have 2 pieces, one headed for New York, one headed for LA. I don't want 2 pieces because we don't know what'll happen when you blow it up. So the kinder, gentler solution would be to nudge it out of harm's way. And all you have to do is nudge it so that it misses the keyhole. And that's only a 300-mile nudge, one way or another. And if you get it early enough, you give it a sideways motion. I'm headed towards you. Give me a sideways motion, a few centimeters per second, that accumulates so that after enough time, and I miss you completely. And in this case, you just have to miss the keyhole. 2029, that's the right amount of time in the future. Most of us will still be alive, we hope, and we can adjust budgets to make this happen. So all we have to do is engage international space agencies to do this. There are none. There is no organization to do this. And who's going to pay for it? We would surely pay for that, but suppose it was headed for the Indian Ocean. Doesn't affect America. It wouldn't affect us. So what kind of Earth insurance policy does the world take out? How do you work that? And we have an Apollo 9 astronaut, Rusty Schweiker, with a webpage called B612. dedicated to studying not only the physics of asteroid collisions, but the politics of how to alleviate them. B612, where have I seen that before? B612. That is the name of the asteroid that the Little Prince landed on. Oh, isn't that the cutest thing you ever heard? So that's B612. So people are thinking about it, and even some influential people. So if we don't mobilize in time, because we have too many lawyers among us and not engineers, like we can always get on the case of lawyers, right? Because I'm not alone. How many lawyers are here? Raise your hand. Oh, there's a lot. Yeah, there's a lot. Okay. But everybody makes fun of lawyers, right? In fact, my favorite lawyer joke was told to me by a lawyer. Can I tell you what that was? Can I tell you? He said, it's the 98% of all lawyers that give the other 2% a bad name. So I thought that was pretty funny. Lawyer told me that joke. That's pretty good. That's a pretty good joke. So here's what happens. If we don't mobilize in time, and it does thread the keyhole, we still have another 7 years. The problem is it's headed straight for Earth now. Now when you have to deflect it, you've got to deflect it by 4,000 miles by Earth's radius. That's a much harder job than deflecting it 300 miles, half of the keyhole. So I suggest that NASA go ahead and do this just as an exercise. Even though it's only a several in a million chance of it hitting, I want to know that we have the power to deflect asteroids so that we do not suffer the same fate as our reptilian ancestors 65 million years ago, who did not have engineers among them, so that as they're standing there dining on our mammal ancestors as hors d'oeuvres, I'm reminded of the Gary Larson comic. A T-Rex is talking to some other T-Rex, and they're just sitting there, just chilling, and one says, "Now is the time to build an asteroid defense system." Because I don't want to be the laughing stock of the galaxy, where others know that we were smart enough to have a space program, but too dumb to put it into effect and to save us from our own extinction. So thank you all for coming this evening. Thank you. Actually, wait. Actually, I want to... Actually, I have one encore, if I may. Can I call it an encore? Okay, I have a thought that I find completely disturbing that I just want you all to have so that you will lose sleep tonight just as I do. Are you ready? This will be our parting thoughts together, okay? Humans tend to be unjustifiably hubristic about who and what we are in the animal kingdom and in the world. Just one example. We have these books that have optical illusions in them. Who doesn't love a good optical illusion? We all love optical illusions. The simpler, the better. Why do we call it optical illusions when it really should be called a book of brain failures? Because that's what it is. Oh my gosh, is it out of the diagram? I can't figure it. It's brain failures. We don't call it that, but that's what it is. Okay, we think very highly of ourselves. We call ourselves intelligent. By what measure? Oh, so we list things that we do that no other animals can do. So we say, oh, we have poetry and philosophy, and we have the Hubble telescope, and we compose symphonies. We're intelligent. That is our measure. All right. Well, I studied this briefly. And you ask, well, what is the next closest species to human beings? It's basically the chimp. Okay? And how much DNA do we have in common? It's like 98% identical DNA. All right? But we are prone to say, oh, but what a difference that 2% makes. All the chimp can do, maybe it can stack boxes and reach a banana. Maybe. Maybe it can combine a few hand signals. Maybe. But look what we do. So we are convinced that whatever is in that 2% is significant. But I want to pose to you a disturbing thought. Maybe the difference in our cognitive capacity between us and chimps, we and chimps, maybe that difference is as small as that 2% suggests. Maybe the Hubble telescope and our greatest of operas and music and poetry is not much different from stacking boxes and reaching a banana. You say, Tyson, how could you say, what do you need, what, just look, look. Well, that's hubris. Because imagine, in whatever is this cognitive scale, oh, by the way, the smartest chimps, the primatologists roll them forward and they're doing what our toddlers do. Isn't that right? Our toddlers can stack boxes. Our toddlers can put up an umbrella. Our toddlers can make sign language. That's what our toddlers do. But those are smart chimps studied by the primate experts. Imagine a species 2% beyond us in the same scale in which we are 2% beyond the chimp. How smart would they be to us? Well, let's just think about that. If they're as smart compared to us as we are to chimps, then to them there'll be no difference between stacking boxes and the Hubble Space Telescope, because they'd be capable of mental feats far beyond anything we could possibly conceive. Their humanitologists would roll Stephen Hawking forward and say, this one is slightly smarter than the rest, because he can do astrophysics calculations in his head, like little Junior over here does. Our greatest works of art and literature and science, their toddlers would have created in their kindergarten and would be on their refrigerator with magnets. Oh, look, little Junior just derived all of quantum mechanics. Isn't that cute? Put that on the freezer door. Oh, is this your 20th sonata? Oh, that is so cute. We call ourselves smart. You don't know if you're smart or not until you have another species blow you out of the water. And what I'm about to tweet this evening, because it disturbs me, I got to get it off my chest. There's a worm in the street. You walk by it. Does the worm know that you think you're smart? The worm has no concept of your smarts, because you're that much smarter than the worm. So a worm has no idea that something smart is walking by it, which makes me wonder whether we'd have any concept if a super species walked by us. Maybe they're uninterested in us because we're too stupid for them to even imagine having a conversation. You don't walk by a worm and say, gee, I wonder what the worm is thinking. This is not a thought that you have. So one of the best pieces of evidence for why we haven't been visited by aliens is that they have actually observed us and concluded there is no sign of intelligent life on Earth. Thank you all. Thank you. Thank you. Thank you.